Now there is one problem with this manual allocation of values, and that's being kind of tedious and not very transferable outside of what you're doing. So if I were to change this 4, so instead of having an array of 4 elements, let's say we've got 250. Are you really going to spend the next hour and a half writing, my first array 3, my first array 4, all the way down to 250? If you do, there's, I don't know, you've got a lot of patience, but it's really not a good idea. One, because it's a waste of time, and 2, that you have, that's just for your input. What if the user wanted to input some sort of data? You can't have all 250 here and make them enter 250 things. You're going to want to automate that somehow. And one way to do that is by wrapping it in one of the loops we discussed in part 1. A good loop for this is a for loop, and I'll just show you why. We delete this and just have our definition here. So we've got 250 elements. Cool. Now let's write a for loop. So remember, the 3 stages of a for loop is the starting position, the termination criteria, and how much to increment or decrement by. So if we create an integer, call it index, and make it start at 0, and good thing about this is that because arrays start at 0, we have a nice little starting value here. And now we can say whilst index is less than 250, because that's the number of elements in our array, or our max storage size. And then, let's just add 1. So we go through 1 at a time. Sort of simple. And now what we can do is start filling our array with values, but we can completely automate it, because whatever's in this loop will always work continuously until this criteria is met. So it's going to do it 250 times because it starts at 0 and it increments once. So let's grab my array, and just how we indexed earlier manually, when we did 0, we can replace that 0 with the index variable that we created, because this starts at 0 and then its value changes by 1 every loop. So it's going to start at 0, then it's going to go to 1, then it's going to go to 2, all the way up to 249. And that's really good, because then we can loop through our array. So let's actually set the value of index into this position. So we should have a list of 0 to 250, 249, yeah. And then shall we just print out this as well, so we get a good track of what's going on. Right, so we've got 2 lines of code here instead of 250. Or 5 lines if you want to be pedantic. Nice, so we've saved it. Let's go back into Unity, let it recompile, and let's see the fruits of our labor, essentially. So if we click play, we should have a huge number. There we go. It starts at 0 and it's gone all the way down to 249. So 250 prints with just 5 lines of code. And that's really important to remember, having these sort of automations, that's going to cut development time, increase productivity, and make your code just more robust, reusable, portable, idiot-proof, But we can optimize this even further, in a way. We've got this 250 here. This is a hard-coded variable, but it could relate really to anything. What if in the future this value changes, or we delete this array, remake it, and have 251 slots or something? Because we've got this hard-coded thing, we have to go back into the source code, change this, save it, recompile, and then push it out as a new patch update or something. It's not very not very good. You want that to just update on the fly. So what you could do, there's two things you can do. The first of which is to create an integer, and let's call this max value. And let's give it the value of 250. And we can pass that in. That's all well and good. But that's also not the best way of doing it. In terms of this value here, because it's a max value, perhaps we don't ever want it to change. We want it to have this and that only. So to really force it to do that, we can give it a constant type. And the shorthand for that is, if you write const and then the data type, that means, this keyword means this variable will have one value only forever. It's never going to change. And usually you would give constants a all caps like notation, so that anyone working with your code can see, oh, that's obviously a constant. Whereas if you wrote it, like this, it just looks like a normal variable, and you're thinking, what if I want to change that? And then it complains, and then you find out that it's constant. So cut out that middleman and just adopt this notation in the future. Okay, and because it's constant, we have to actually declare and define the value all on the same line. So that's something to be aware of. If I got rid of this, it's going to be like, ooh, you need a value, so let's give it a value, 250. And now we can pass this constant into here, oops, like that. And now we're saying, oh, why it's less than this predefined constant, do this. So that's a neater way of hard coding, and we can obviously replace this 250 with that variable as well. And because it has a name, it's much more meaningful. Right. And the final way of doing this is, you can have this constant, pass it into here, and then in your for loop, you can use the length of your array, as in not your integer, but the actual length calculated as this criteria. So what we can do is we type in our array here, so my first array, and then use the dot operator, so we press full stop. It brings up a whole list of stuff, but the one that we're concerned with is length. And if we read it, if you hover over it, it's not saying it here, but what it is it gets the entire length of your array. In this case, it's 250. So while it's less than 250, so it should still run a full 250 times, but it will stop at 249. Do all this. Right, so that looks all about right. So we'll save it, go back into Unity, let it recompile. Now we're going to click play, and what's going to happen is exactly the same as before, but it's just a more robust way of doing it. So get into the habit of coding anything that's hard coded, like the 0 or whatever, these zeros, recode that into a variable so that makes more sense to you later on. It's more robust, it's more reusable, and when you look at your code in 1 month's time, you're going to look at that number and think, you know what it does, because it is a variable. If it was just hard coded, you could sort of work it out. If it's this, you can kind of work out, okay, that could be the length of an array because of what's in here, but it requires a bit of extra thinking, or sometimes, in some cases, some numbers you've typed in make absolutely no sense at all, and you're thinking, I could only 2 people could read that code when you first wrote it, you and God. And when you're looking at it in 2 weeks' time, only God can read your code. Yeah. So just get used to putting your hard-coded values into variables. It just saves a lot of stress, believe me. Okay, so that's your array. Perhaps now we want to search through our array. So this created it. Let's make another for loop to index through it again, Let's call it index. We'll call it index 2, why not? Give it a value of 0 to begin with, while index 2 is less than the length of the array. Oops. Let's increment by 1. And now we can use those if statements that we went over earlier on to check, what we're looking for. So let's say we want to find the number 5 in our array. So let's have an integer called target, and let's make it equal to 5. Cool. And little green things there because we haven't actually used the variable yet, but don't worry because we're going to use it now. So we're going to loop through here one at a time, 250 times, and we're going to check with an if statement. Hi, Kanata, RS. Yeah, so we're going to check with an if statement. If open brackets, and in here you put your criteria. So if the current sort of indexed position in our array, so remember we start at 0, this will eventually change to 1, 2, 3, 4 all the way up. So if this is exactly the same as the target that we want to find, then we open our curly braces because we need to put the code inside here, which is related to our if statement, not the for loop. Then we can print out something, we found it. And because we found it, we can just break out on that first instance so that we don't have to index through the rest of them. And that saves a lot of computational time. If we haven't found it, let's say we'll print out again and say, not found. And because this is in order, just because of how we did it, I predict that, not found will be displayed 4 or 5 times, and this will display once, and then we're done. So let's go ahead, save that, go back into Unity, clear this, let it recompile, and then we hit play. Yeah, I'm very well, thank you. How are you? Right, so we've got all these here because we printed all these out. Probably should have stopped that. I'll scroll down, and it says not found, and we look here, the little button, so it says, oh, we haven't found it 5 times, but then beneath it, after those 5, we have found it, and then we've broken out. So that's the general premise of searching through an array. If we got rid of this break, what would happen is this not found would display far more often than we would like because you're searching through the rest of something. So if we scroll down here now, we've got not found 249 times, and we found it only once because 5 only exists in this array once. So you may want to break out on the first instance, or you may not. You might want to have a count of all of the occurrences that thing appears, and that depends on what your implementation is, what you're coding, who knows. And I'm not using this code for anything really, it's for educational purposes. I'm teaching sort of beginner introduction to C# programming, but through Unity. So we're starting off with console printing, but then we're going to move into actual Unity based stuff, so coding stuff for objects and moving things around and so on. It's more of like a big recap of variables, if statements, loops, methods, arrays, coroutines, method overloading, things like that. Yeah. Right. So normally people associate for loops with arrays because of the nature of that loop, because it indexes one at a time or however many you like. But you can use a while loop. If I were to do that quickly, let's say while, we would have to declare the index outside, make it 0. Oops. We'd say, oh, okay, while index is less than my first array dot length, and then in here you can, put in the same stuff. So you can do that, but it's a bit wasteful because you could just have a for loop that has this internal variable here, and there are benefits to it. There's not just a personal preference thing here. The benefit of having the for loop version is that you're creating the variable inside the scope of the loop, and as soon as this loop has finished, that variable just gets cleaned up in memory, so it's not taking up any space. Whereas if you're doing it like this, because you've declared it outside, it doesn't get cleaned up at the end, so you're just sort of wasting memory. So there is a reason why people use for loops over while for that particular scenario. Yeah, so that's a bit of trivia for you. Okay, so that's pretty good. I think in terms of arrays, you could do insertion and deletion, things like that. So if you wanted to insert targets, let's say we use the same code here. You look for the target 5. Once you've found it, let's replace that value. So we're using the same index with, I don't know, the value of 10. And then what we could do is print out the index before and after, just to double check that it is doing as what it should. And what we'll do is we'll just get rid of the other print, so that it's not too convoluted, not too chaotic. And then we'll get rid of this else as well, because we're not interested in that yet. And then what we'll do is just break out. We'll let that recompile. Save the scene as well, so it doesn't crash or my laptop doesn't freeze. And then we'll hit play. Okay, so before it was 5 because it was the first instance and we found it, and then we changed that number 5 to the value of 10, and then it printed to the value of 10, and then we just broke out of the loop. And then deleting is the same sort of thing. However, you would most likely flag the value with something that's not going to interfere with the calculations that you want to do. So for example, if all of your elements could be positive, it's safe to assume that if you replace this with -1, it's not going to interfere with your calculations, and then that's a good indicator of something that's been deleted. So it's still there, you're just not going to include it in your stuff. So you can have an if statement that says, if the index doesn't equal -1, meaning just skip over those, then execute some criteria. You could do that. There's a keyword called null, and that really does just sort of remove things. There has been some debates on whether or not you should use null from sort of like a memory point of view, but yeah, these sorts of things you need to consider. So there's true deletion, where you actually eliminate something, and then there's just flagging it, so it stays in memory, but it's not going to concern you, that sort of thing. So for now, I would just do this if you really want to delete something, but yeah. So that's insertion, sort of introduction to deletion. Because deletion is a bit more complicated, and I don't want to get into it yet because of these fundamentals, so I'd just recommend practicing writing arrays, writing loops, automating the insertion or creation process. Think about how to search through them. Think about what you could use them for. The ammo count is just an example. All manner of things. A player's inventory could be an array. Anything where you catch yourself writing tons of variables of the same data type. Think, could you just change that to an array? That sort of thing. So yeah, brief overview, but you can't hope to know everything from this one stream. You have to program it yourself, read some things, but really just start coding. It's all muscle memories, skill-based learning. You have to do this, otherwise it's just not going to sink in. It's not something that you prepare for a test for. You don't just memorize it and then hope you pass and then you can put it to bed. You really have to work at it. Just like speaking a language, because it is a language at the end of the day.